21 minutes. Okay. Good evening, everyone. My name is Fofana El Haj, and I belong to the group name called Ninjas. And today I'm going to present you the video that will go through the project that we have done. So let me move you over the algorithm of the project. But before moving over the algorithm, I'm going to tell you what the project was about by showing you first the summary. Okay, like you can see at the title, our project 2 name was Industrial Analysis Theory of Constraint, right? And as you can see here, the main idea, the main goal of our project, of our team, was to compare two methods that will of two methods that combat the construction. And one method name is the traditional method, and the second one name is the bottleneck method. And throughout our code, we are going to compare the contribution margin of each and see which product has the highest benefit to the company. Okay, this project actually is a little bit related to economy. So now let me move you over the algorithm. We are going to go over the algorithm really quick so we can move on to the real code now. Okay, the algorithm is divided in 6 parts. So now we are going to start with part 1, data input and validation. In this part, we have couple tasks. The first task is to put the company name, input and operation, plus the number of week of data validation. We are going to ask the user to input the company name and the week per year as a cell array, and we will check that if it is not a cell array of a 1x2 matrix, then we are going to show the warning and tell the user to enter until he enter the right one. And we will check if the week enter is between 1 and 51. It shouldn't be any more than 51, and if it is, then we are going to ask the user to enter it again until he enter the right one. Text 2, product name and input private data validation. It is the same, practically the same as the first one, but this time it is the product. The user will enter the product name as a cell array. It doesn't matter how many names the user enters. He could enter 3 name, 4 name, 5 name. It's up to the user, as long as it does not mean the criteria, which means it's not entering any name, because you have to enter at least one name. Test number 3, machine name, input and data validation. Here we ask the user to enter the machine name as a horizontal vector with at least one name, and if it doesn't meet the criteria, we will display an error and get him out of the programming anyway at that moment. Text number 4, machine availability. We ask the user the available time per week each machine work actually. And then the text number 5 for the first part is the data collection. The user will input for each product the machine hour required, unit material cost, unit labor cost, selling price, and monthly demand in separate vector for each type of entry. Part number 2, calculation. The calculation part, this is where the big deal is. Number 6, text number 6, we are going to do a conversion. We will do the calculation of the yearly demand for each product and the yearly demand availability for each machine. And then after that, we will print out and tell the user that the conversion has been made. Test number 7, contribution margin. We will do the calculation of the contribution margin for each product by subtracting the cost needed to produce each machine total from the selling price of each item. Calculation of the total contribution margin for each product in others variable. And then after that, we are going to print out a thing and telling that we have done the calculation of the contribution margin. Part 3, data combination. Part 3 is about combining all the data that the user has input so far during the part 1 and the part 2 of the contribution data calculation, and we will enter that in a single matrix. We will combine the selling price, the material cost, the labor cost, the demand, and the total contribution, as well as the machine usage, as a single matrix. That will be text 8. And then after that, we are moving to the 4th part, which is a delicate one. Traditional method. Traditional method actually has three takes, starting from takes 9. Traditional method function. How do we do the traditional method function? To do that, we are going to create a function named sorting with input as the combined data matrix and the combined margin. And in the function, we will sort the data on the contribution measure from greatest to least as a single matrix corresponding to each product and its component. And after that, we are going to print out the sort data that we have and tell the user that the traditional method result has been displayed. And then after that, we are moving to text 10, finding the traditional method of product mix and bottleneck machine. Using traditional method, we are going to calculate the unit of each product type that should be made and saved in a matrix. We will print that of the bottleneck machine after finding the bottleneck. Text number 11, traditional net profit. After asking the fixed cost of the manufacturer, we are going to calculate the net profits and display it on the command window. How do we calculate the net profits? The net profits is the production cost minus is the benefit cost, the selling cost of each product minus the production cost. I'll show you when we get to the code. If net profit calculation is less than 0, warn the manufacturer that they are losing money. The bottleneck method, case number 12, identifying the bottleneck and using the sorting function again. In this process, we are going to identify which machine is the bottleneck and calculate the contribution margin per hour of the bottleneck machine usage. Replace the last column of the combined data matrix from text 8 with the contribution margin of the bottleneck machine calculated. After that, we will input the new combined matrix to the function created in text 9, sorting, and then we output the single matrix setting from greatest to smallest, the contribution margin per machine time. This is actually the same as the previous traditional method. All we are doing here is to change the calculation method. Instead of traditional, we are using bottleneck. And in text 13, we are going to find the bottleneck method of production width. We will calculate the unit of each product that should be made using the bottleneck method and save data in a matrix. Text 14, bottleneck net profits. Just like the traditional net profits, we will calculate the bottleneck net profits and using the fixed cost acquired and displayed on the command windows. Text number 6, exporting data. This is the last part of the algorithm and actually the test. And in this last part, we are going to ask the user to combine and export the data. Produce product mix data for each method should include a product name, number to be produced and contribution measure of each product. Export the product mix data in a CVS file, name of the company input in text 1 as name of the file. First, export traditional method of product mixed and then bottleneck data with line below, the traditional one and one empty now. Okay, so far this is what the project was about. Now we are going to do the test cases. I'll show you a little bit what the test cases is about. So you see here, as you can see here, we are going to ask the data to enter what is the name of the machine. We will enter that, and then we will enter also the salary, the name of the company and everything, and then the calculation. This is what it should be looked like. Here we have two product, blanket and scarf are the two products, and at the very end of this matrix, this salary matrix you are seeing here, over here, this is the contribution margin over there. See where the month is at this moment here. This is the contribution margin, the very last one right here. Okay, so using the traditional method, blanket demand should be fulfilled first. The overall contribution margin for that product is, you see, 16,800. Okay, final data contribution, and here we are calculating the contribution margin. Okay, so far this is the algorithm of the project 2 that I've shown you for now. Okay, without spending any more time, let's move on to the real code. So first, let me open it on my command window. Okay, project2. Okay, ninjas. It's going to take some time to load it. Okay, that's not loud. What? Oh, here? Yeah, pause. Why is this taking too long? It's not pausing, bro, but it's okay. Okay, everyone. So this is the MATLAB code that we have typed for this project so far, and I'll take you through this code and explain you step by step what is there and let you know about our code. Okay, as you can see, each part is written and we have commented each task as well. So we've started this code with the, of course, the first comment CLC clear close all. And the text one, as I explained in the algorithm, we are going to do the company name input and the number of week data validation. We are going to ask the user to input that using info. The function info is the one using it. And we have used tf equal is cell info in order to make sure that the what the user is entering is really a cell array. And after that, we are using a while to see if the data the user enter is right and is in the range. If not, we are going to give him a warning and make him input it again. And the same goes again for the number of week he entered. We use a while statement over here on this part and let him do this calculation. Same goes for this part too. All of this is for the data validation, right? The test2 is the product name input and target data validation. The first one here was for the company. Now here down here for the test2 is for the data validation, right? Okay, I'll take you through this. Name input, please input the name of the product as a cell array. tf equal is cell array, just to make sure that name is a cell array as well, right? Okay, so here we have R2 equal 0. If these are the data validation for the product, you see here all of these part are data validation for the product. Okay, and this part as well, all the way down here are data validation for the product, and this part as well, you know, just like as explained it in the algorithm actually cover everything, a big understanding of the program. So here I'm just showing you, how we are going to display the code, the warning we are using, and the cell, just to make sure that the function we enter is a cell array, and the size of the function as well. All of these while statement. And here we have to transpose the name of the product entered, right? That's why we transpose it. We said name equal to name prime, just in case. Here, if you can see it in this part, I'll make it in blue so it appear well. You see that one? Good job. So here, let's keep going. Text number 3, machine name input and data validation. Same thing for the machine, just like for the product and for the company name, we are going to do the same for the machine name. We ask the user to enter a machine here, right? Here, please input the machine name as a cell array. and TF just to verify that it is really a cell array, right? And here we have the size of the machine in order to do our data validation. And everything here is the data validation that I have been talking about in the algorithm. You see, everything down here just to make sure that it is in the range and it is correct, so that our code can be very flexible. So we use a while loop. Every time he enter the wrong one, we are going to warn him and make him repeat it again. You see, all of these are the data validation for the machine name input. Let's keep going. Text number 3, we have the machine availability, right? We create a machine per hour, you see, equal to an empty cell array, hour per week, just like it is mentioned in front, right? We are using this if loop, for loop here to ask the user how many hours per week is percentage s available machine number, right? Just for the code to be flexible, we did not hard code it. So it's going to enter the amount of machine, because we do not know how many machine it will enter. So it's going to enter the amount of hour of each machine availability. That's why we use the for loop. 1 equal to 1 to the 6 to the third. That's the amount of column of the machine, since it has to be a horizontal vector. Okay, horizontal cell array, by the way. Yeah, so yeah, this part I'll repeat it again. This part is for the for loop to enter the machine availability per hour. And here we have machine hour, material cost, labor cost, selling price, and demand. All of these are the inputs that the user will enter, right? So he's going to enter the availability of the machine cost, labor cost, and demand for each machine that he will enter. To make our code flexible, we make it appear like this: machine G, name I, just in case, so our code can work for many machines and many products instead of two, right? Sorry, I just scroll down too much. I'm going up here. Yes, okay, all right, let's go, let's keep going. Yeah, let's keep up from here. So if you see, we are done with the part 1 already, which was the data validation, right? Hey, let's keep going. Now you are starting the part 2. Part 2 is the calculation, as you can see over there in the board here. Calculation. 20 minutes. Okay, so now here, as you can see in Texas, we have conversion, calculating the yearly demand for the product, calculating the yearly machine availability. So y / demand 2, and we have cell array, that's the demand for here. M / availability, we have open 2 empty cell array for the machine availability as well. And we uses this for loop just to ask the user to give us the machine availability, right? And the machine demand. This for loop is going to give us everything without hard coding it. Okay, and the up here, this is for the machine demand. And down here, the next one I'm going to bolt is for the machine availability. Okay, now we use this post function here. It is not very important, but it is good because it's going to help us, separate each part of our code so it can run perfectly. You see, and here we f the statement telling that the conversion has been complete. Take 7, contribution margin. Here we are using a for loop to calculate the contribution margin for every single machine enter. We are using the contribution margin. You see, so we have to use the for loop and use also the column of the very vector that we have entered up here, C2. If you can see, we have a colon. Okay, here I'll show you up here in the code. Where is it? Okay, that's R3. It is C2. I went over that. I'm going a little bit back. Okay, right here. You see, right here, C2. There you go. Yes, that's for the product name. So we can have many product names. So C2 is going to be the product name. You see, the column of the product name for every column of the product. That's why we use C2 here, because each demand will be concerned to each product. And here the availability is for the machine, right? That's why we use C3, the column of each machine, and the hour per which the machine is available multiplied by the info, right? To make our code flexible. Again, we use pose to make it work. Okay, here the contribution margin, we use C2 as well. The contribution margin for each product, that's why we use C2, and then we pause it just to make the code run well. The contribution margin has been calculated. Good. Now we move to part 3, right? Part 3 is where we are going to create a combined matrix, right? So data C equal to an empty vector C equal to 1, and we have data C equal to this. You see, this formula is being given, right? Because we are combining all of them: name, machine per which hour, machine 2, selling price, and everything, right? Okay, so let's keep going.